Hi guys, and welcome to Unit 7. I am Kat Truteau and I teach at Winston Churchill High School in Potomac, Maryland. I'm going to be taking you through the first half of Unit 7, starting with 7.1, an introduction to air pollution. So in this unit, you're going to be seeing all different aspects of air pollution, but today we're starting out with this very beginning, and we're going to take a look at primary versus secondary air pollutants in this video, as well as the major legislation, the Clean Air Act, that is involved with helping to maintain air quality standards for us in the United States. So what are we going to learn? Well, for the entire unit, we are going to be keeping one enduring understanding, which is that human activities have physical, chemical, and biological consequences for the atmosphere. And in 7.1, our learning objective is to identify sources and effects of air pollutants. But today, in this video, we're only going to deal with those two things I discussed. We're going to look at primary and secondary air pollutants, what's the difference between those, and we're also going to be looking at the Clean Air Act and its National Ambient Air Quality Standards, specifically the effect it's had on lead in the atmosphere. So, primary and secondary pollutants, what's the difference? Well, let's start with what is air pollution. For air pollution to be considered air pollution, it needs to meet two criteria. It needs to be in the atmosphere, and it needs to be harmful to humans or to the environment. That's the definition of air pollution. Now, air pollution can be a primary pollutant, which means it was emitted directly into the atmosphere. Some examples are things that come from natural sources like pollen or volcanic ash. We also have volatile organic compounds or VOCs that are given off by plants. Or they can come from anthropogenic or human-caused sources. We'll especially be focusing on the combustion of fossil fuels and all of the different types of air pollutants that are created by that process. So those are primary. Again, they are directly emitted into the atmosphere. Secondary pollutants occur once those primary pollutants are in the atmosphere and they interact with other atmospheric gases, with each other, or in the presence of sunlight. Ultraviolet radiation can break down some of those elements. And so we might form new molecules, new types of pollutants. So in this video and throughout the unit, you're going to be seeing some examples of primary and secondary pollutants. Some examples are tropospheric ozone. That's the ground level ozone that's down here with us. That is harmful, different than stratospheric ozone, which is up there, which is helpful. We'll also talk about acid rain as another secondary pollutant. So let's look at an example. This picture shows us the primary pollutants and secondary pollutants process coming from some natural sources, also coming from some man-made sources. But what I like about this is that we can see the direct emissions of those primary pollutants if we follow the arrows, and we also see secondary pollutants formed from the primary pollutants. It doesn't take much chemical background to see things like SO2 translate into H2SO4 or SO3. So we have interactions in the atmosphere, maybe with water vapor, maybe with the oxygen that's up there on its own. But those secondary pollutants are formed once they're in the atmosphere. Okay, so the second thing we want to talk about in this video is the Clean Air Act. Now, the Clean Air Act was passed in 1963, but it wasn't until 1970 that and you don't need to know the dates, that we had the National Ambient Air Quality Standards come along. And those set goals for the EPA to really help protect human health for 6 main pollutants, which we call the criteria air pollutants. Those pollutants are sulfur dioxide, particulate matter, lead, ozone, nitrogen dioxide, and carbon monoxide. So you should be familiar with all of those. If you were asked to list the 6 criteria pollutants, you would need to know all 6 of them. I've got a tip for you though. There's a mnemonic, SPLONK. The first letters of all of these pollutants spell out SPLONK. What is Splunk? It's nothing, but SPLONC, it's just a helpful way to remember our criteria air pollutants. I do want to point out a couple things about this. A lot of times students see the P and they think about lead because you have PB there as the chemical symbol. The P is for particulate matter, the L is for lead. The other thing that students often miss is that this is carbon monoxide. These criteria air pollutants are things that are very dangerous to human health. And while carbon dioxide is problematic, and we will talk about it in this unit, it's carbon monoxide that is poisonous and deadly to humans. So these criteria air pollutants, these NAAQs, this is what we're focused on. Now, one of the really great case studies that came about because of these air quality standards is the reduction of lead in the atmosphere. So when you think about lead, you might not even think about it as being an atmospheric pollutant, but it was, because in the 1920s, we started to use lead as an additive to gasoline. It helped improve octane ratings, and it wasn't until the 1960s that it was discovered that lead had some very detrimental effects. So for children, and again, we might know about this from water, from paint, from other types of lead applications, but we know that lead has severe effects on children, leads to anemia, behavioral disorders, lowered IQ, reading and learning disabilities, and nerve damage, even in low doses. And it can affect adults too in hypertension and cardiovascular disease. So this was a major concern. And again, it was in our gasoline. This is why when you go to the gas pump, you will see that all of our gas says unleaded. So that has been mandated by the EPA, and almost every country in the world now has unleaded gasoline mandated. When we phased out leaded gasoline, we also saw a decrease in the lead levels in children's blood. So this has been a great success story for the Clean Air Act. Over time, this graph just shows you that we are doing great. We are still making progress up until 2019. You can see that the levels of lead in the atmosphere continue to stay low, and they have dropped quite a bit. So what are we going to take away? Atmospheric pollution can be natural or anthropogenic, caused by humans. We talk about it classified into two categories. Primary air pollutants are emitted directly into the atmosphere, while secondary pollutants form in the atmosphere. The Environmental Protection Agency has, under the Clean Air Act, the National Ambient Air Quality Standards to protect us from 6 criteria air pollutants. And you're going to remember those with the acronym SPLONC. And lead is particularly harmful, but it has been decreasing since the adoption of these national ambient air quality standards. All right, next time I'm going to share with you guys a little bit more about air pollution, and we'll start to look at some more specific types. So we want to practice with our science skill today, and our science skill is to explain modifications to an experimental procedure that could alter results. So I want you to pause the video and read this prompt. Okay, so we're going to explain one way that you could modify this procedure to better determine the impact of fossil fuel combustion on sulfur dioxide levels. Take a moment to think about how you would answer that. So there's a lot of ways to go with this question, and you'll see that on FRQs. We want you to be thinking critically about what you could modify. Maybe you could try to burn some coal, lignite, bituminous, and anthracite. Maybe you could adjust the temperature that you're burning these fossil fuels at. Maybe you could change the volume of the burning. Any of these would be acceptable. Make sure that you explain what the variable is that you are going to change and what you expect to happen for the outcome. So let's do a quick practice. So, which of the following is a secondary pollutant from fossil fuel combustion? Here's a trick. They're all pollutants and they all come from fossil fuels, but only one is a secondary pollutant. So did you find it? It's tropospheric ozone. It's created from nitrogen oxides. So it is a secondary pollutant.